circuit, I implemented two BJT transistors and two LEDs to demonstrate a latch. A latch can be set to 0 or 1. We can consider the output to be our right LED. Right now it's set to 1, and our input will be the switches. So the left LED will just represent the complement of our output, which right now is set to 1. So if we reset, it will be 0 and our complement will be 1. If we set, it will be 1, complement will be 0, and it will remain in this state for as long as there's power. So yeah, this is all done with the mechanics of the BJT transistors. This circuit represents the two-state machine that you have using two transistors, two capacitors, and four resistors, and two LEDs. There's an action that's triggering this. That's just how the circuit behaves, and it's taking advantage of the charge and discharge time of the capacitor. Remembering that BJT transistors consist of two junctions of N and P-type impurities that will allow for current flow between collector base and emitter. In a similar way, we have the MOSFET, which stands for metal oxide semiconductor field effect transistor. That is structured where we have our P or N type base or substrate, and we have two regions of impurities added of N-type or P-type semiconductor. Then we have an insulation layer between a conductive metal layer and top of our substrate, but it's not directly in contact with it. This will form our source, gate, and drain. And the way this transistor is turned on, it's by applying an electric field that will enhance the current flowing between the source and drain. However, this does not allow current flow between the gate and the source or the gate and the drain. Our MOSFET circuit here is able to amplify our input to our gate voltage, which has a sine wave of 50 Hz. And we can see the input in blue, the output, where we're measuring the output voltage, it's in yellow. So we can vary that amplitude of the output by just adjusting the input to the gate voltage. So this, again, a MOSFET behaves similarly to a BJT, but the way they're controlled are different. MOSFETs can be found in the form of discrete transistors, or they can form part of a integrated circuit, which is a chip containing a set of circuits that will allow for specific functionality, such as an amplifier, an oscillator, or a microprocessor. The reason for MOSFETs being very popular on the fabrication of integrated circuits is because they are very compact and they are very easy to mass produce. This following integrated circuit will demonstrate a flip-flop, and we need a clock, which is this 555 timer, which has an LED that will show you if the clock is high or low. Our output Q, which has this LED to represent the current state. And here we have 4 switches. 2 of them will be to set our value of D, and then the preset and clear are the top and bottom. So here, for example, typically we want to wait for a clock rising edge for the flip-flop to take our input, but the preset and clear are asynchronous. So if I just hit this one, will write. If I hit this one, will also write. So like that. So we need to wait for the clock cycle. Now, it's not the same as if you want to write, let's say 0. I can press as many times as I want, but it will not take my input until the clock it's rising. So again, I'm gonna press it many times, nothing happens. Now if I keep it hold until in the new clock cycle, then it will latch that value. So yep. Now same thing happens with this, and again This is 0, this is 1, waits for the clock, and then it takes it. 0, waits for the clock, and takes it. Same thing, pressing 1 and cannot do anything until it waits for the clock, and then it takes it. Alright,